Dear students, in this video I am going to explain about an important topic, that is parabola. Okay, so the contents of this topic are introduction of parabola and equation of parabola, standard form of parabola. Next, some important definitions like chord, focal chord, double ordinate and latus rectum. Chord, focal chord, double ordinate and latus rectum. Next, some important properties of parabola, some interesting problems of parabola. Okay, we will solve some problems, right? So before entering to parabola topic, first of all I am going to explain about conic or conic section. What is conic? Okay, right. So the locus of P from a fixed point. So this is point P, this is fixed point S, and this is fixed line. This is fixed line. Okay, let us take one point here M. Okay, so the locus of P, which the point moves P, the point P moves like such that the ratio between SP and SM is equal to constant. Okay, so the ratio, this point P moves with the condition SP by SM is equal to constant. Here SP is called as distance between fixed point and the point P on the locus, and here SM is called as PM is called as the perpendicular distance, okay, which is called as shortest distance, the perpendicular distance from the point on locus, the point P on locus to the straight line. Okay, so to the straight line. So this is fixed point and this is fixed line. Okay, right. So this ratio SP by PM is called as constant. Okay, so this constant is called as E. This constant is called as E, which is called as eccentricity or eccentricity. Okay, so SP by PM is equal to E. So then the locus which is formed by point P is called as conic. Okay, so in geometry we are going to learn three types of figures. One is parabola. So the conditions are, if eccentricity is equal to 1, the conic is called as parabola. Okay, next, if this eccentricity value, that means if both are same, if this total distance and this distance is equal, then the ratio become 1, then that conic is called as parabola. If eccentricity lies between 0 and 1, that is called as ellipse. That conic is called as ellipse. Next, if eccentricity is greater than 1, that conic is called as hyperbola. Okay, so in this video I am going to explain about parabola. Here one more point is also there. So this is called as fixed point. Fixed point is called as focus. The terminology, the fixed point is called as focus. So this is the fixed line. So this fixed line is called as directrix. So fixed point is called as focus and fixed line is called as directrix. Okay, right. Now I am going to explain about parabola, the definition of parabola. Okay, now definition of the parabola. A set of all points in a plane equidistant from, this is the condition, a set of all points in a plane equidistant from a given fixed point and a given fixed line. In the plane is called as parabola. A set of all points in a plane equidistant from a given fixed point and a given fixed line in the plane is called as a parabola. That means here I am taking x-axis and y-axis. So this is a fixed point, and this is a fixed line. Okay, so now identify those all points which are equidistant from these two, that means from focus and directrix. So I am taking a point here. So this is a point and the distance between these two and these two. equal. This is equal. These two distances are equal. So here one point, and I am taking one point here. So the distance between these two equal to this perpendicular distance. Okay, these two are equal, and also same. I am taking one point here. So this distance and this distance both are equal. This is perpendicular distance line. This, let us assume that this point P. Okay, so these two distances are also equal. Like this, by satisfying this condition, we will get infinitely many points. Okay, so the locus of all those points is called as parabola. That means this is the figure which satisfies. These are the locus of the points which satisfies given condition. Okay, right. So this is the required conic. That conic is called as parabola. Okay, right. So the distance SP, and here I am taking a point on this fixed line, that is M. Okay, right. So here SP and PM, all these are equal. Okay, so now question to you: if those two are equal, then what is the ratio between SP and PM? Okay, so as they are equal, SP by PM is equals to, they are equal means the ratio is 1. So just in previous slide I said about this definition. SP by PM is called as eccentricity. That constant ratio is called as eccentricity. If eccentricity is equal to 1, then that conic is called as parabola. This is the shape of the parabola, and the terminology is here. Here this fixed point, the fixed point is called as focus. Fixed point is called as focus, and this fixed line is called as directrix. Fixed line is called as directrix. And some more points here, and here the parabola is crossing the axis here. The parabola cuts our axis here, so that point is called as vertex. That point is called as vertex of the parabola. In another words, also we can say that here the parabola is decreasing. The parabola is changing its direction here. The point where the parabola changes its direction is called as vertex. Okay, right. So this vertex. Next, this is the axis, not a normal axis. This is axis. So this axis is this parabola is symmetric about this axis. This is our parabola. Parabola is symmetric about this axis. So that is called as axis of parabola. Symmetric axis is called as axis of parabola. Here our axis of parabola is x-axis. Okay, so these are the important points of this conic parabola. Now I am going to derive the standard form of the parabola, equation of the standard form of the parabola. So now I am going to derive standard form of the parabola. So how to derive standard form of the parabola? So draw the parabola here. This is the parabola, right? So this is the x-axis, which is axis of symmetry, and this is y-axis. This is fixed point S, which is called as focus. And this is fixed line, which is called as directrix. Next to P, x1, y1 be a point on locus. Okay, here write all those things. Okay, so yes, a comma 0 is called as focus, and L is directrix. Next, A0, 0 is the vertex of the parabola. A0, 0 is the vertex of the parabola. Write all those things here. Now, identify here P is the point on the locus, focus. Now, this distance and this distance, these two distances are equal as per our definition. Okay, so SA is equal to AZ. Next, P as a Px1 by 1 be a point, so draw a perpendicular here. So this is y1 and this is x1. Here this perpendicular meets x-axis at n, so this distance is called as x1. Okay, right. So write all those things here. AC is the focus, L is the directrix, Px1 by 1 be a point on locus, and A 0, 0 is the vertex of the parabola. Okay, next, now observe here. So here M is the projection of P and this Z is the projection of S, focus S. So this distance PM, as this is a rectangle, so this distance PM is equal to NZ. So identify here, PM is equal to what? NZ. PM is equal to NZ. Now NZ is equal to what? NEA plus AZ, which is equal to NEA plus AZ. So therefore, what is PM here? NA value is x1 and AZ value is A. So this is equation number 1. Okay, right. Next, what is the distance between SP? Why I should find PM and SP here? Why means as per our definition, SP is equals to PM. Parabola forms with this condition, that is SP is equals to PM, equal distance. Okay, SP is equal to PM. So for that I am finding PM and SP values. So SP means the distance between these 2 points. What is the formula? Distance between 2 points. So x1 under root of x1 minus a whole, x2 minus x1 whole square plus y2 minus y1 whole square, right? So x1 minus a whole square plus y1 minus 0 whole square. As these two are points, let us assume that this is x1 y1 and this is x2 y2. So the distance formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square, or under root of x1 minus x2 whole square plus y2 minus y1 whole square, right? So this is equation number 2. So as per definition, you know that SP is equals to PM. What is SP here? Under root of x1 minus a whole square plus y1 minus whole square means y1 minus 0 whole square, that is nothing but y1 square, which is equals to x1 plus a. Okay, to remove this square root, squaring on both sides, so you will get x1 minus a whole square plus y1 square is equal to x1 plus a whole square. Okay, right. Now expand this one. What is x1 minus a whole square? X1 square plus a square minus 2ax1 plus y1 square is equals to x1 plus a whole square, x1 square plus a square plus 2ax1. Okay, now observe both sides. So x1 square will get cancelled. Now a square also gets cancelled. What is remaining? Y1 square is equal, bring minus 2x1 to right side, you will get 2ax1 plus 2ax1. So y1 square is equal to 4ax1. Therefore locus of Px1 y1 is y square is equal to 4ax. Y square is equal to 4ax. So this is the standard form of our parabola. So therefore standard form of the parabola is y square is equal to 4ax. Okay, right. So next, general form of the parabola. So in the previous standard form, our parabola is opens left side. Okay, so the parabola maybe opens left side or right side or upward or downward. Different types of parabolas are there. So in next video we will see those types of parabolas. So here this is the general parabola. So here in this general parabola, let us assume that this focus is alpha comma beta, any point in the plane alpha comma beta, and this is the directrix. Okay, this is the directrix, and let us assume that this directrix equation is which is a straight line, that is Lx plus My plus N is equals to 0, and P be a point on the locus Px1 y1 or Px comma y, be a point locus. Now as per our condition, what is our condition? SP is equals to PM. SP is equals to PM. SP means distance between those 2 points, distance between that Px comma y and alpha comma beta. So what is the distance formula? Under root of x minus alpha whole square plus y minus beta whole square. Okay. PM. PM is nothing but the perpendicular distance from a point to a line. Okay. Already you learned this formula in straight lines of first year. So the perpendicular distance from a point to a line is Lx plus my plus n, or if we take x1 y1 as a point, Lx1 plus my1 plus n by under root of L square plus m square. So this is the standard form, or squaring on both sides. If squaring on both sides, what is the condition? X minus alpha whole square plus y minus beta whole square is equals to Lx plus my plus n whole square by square root cancel L square plus m square. So this is called as standard form, general form of the parabola, right? So now I will pose one question, that is, so what is our condition? The fixed distance, fixed point, fixed line. So these are two distances. If these two distances are equal, then we will say that that path of the point or that locus is called as parabola. Okay. Now question. So this is a fixed line. This is a fixed line, and this is a fixed point. Okay. So I am taking a point on that line only. Okay. Point on that line only. So this is a fixed line and this is a fixed point. Now which type of figure we can form? Okay, think which type of figure with this condition, equidistance condition. Okay, so here these are the points. So if we take here, this point is equal distance from this fixed point and equal distance from this fixed line. Okay, and this is the point, equal distance from this fixed point and equal distance from this fixed line. So these are the set of points. So in this case we will not get parabola, we will get a straight line. Okay, so this case is called a degenerate case, exceptional case. So therefore our condition is, okay, our condition is the focus does not lies on the fixed line. Focus and lines are different. Okay, so this focus does not lies on this fixed line. So focus may be here, or here. So we can take anywhere but other than the line. Okay, so this is degenerate case. In this case we will get straight line, we will not get parabola. Okay, right. Now some definitions of this topic. First one is chord. Already you are very familiar with chord. Okay, where did you learn that one? In circles, right? What is the definition of chord in a circle? Okay, so there are 2 points on circle. So the line segment which is joining those 2 points on the circle called as chord. So same definition here. So this is a point and this is a point on parabola. There are 2 points on parabola. This is the line segment which joins these 2 points of the parabola is called as chord of the parabola. The line segment joining 2 points of parabola is called as chord. Okay, so how many such chords can be drawn to this parabola? Right, so infinitely many chords. These are all chords. Okay, so these are 2 points. We can draw infinitely many chords to a given parabola. Right, now what is focal chord? So these are infinitely many chords to parabola. So in these chords, so what is this? This is called as focus. In these infinitely many chords, so some chords which are passes through our focus. Okay, so these chords are passes through focus. So a chord which is passing through focus, is called as focal chord. focal chord. Okay, right. So next, what is double ordinate? Double ordinate, what do you mean by double ordinate? So this is a parabola. So double ordinate means a chord through a point P which is perpendicular to the axis of the parabola. So chord which are perpendicular, this is the x-axis which is axis of parabola, right? So these are the chords which are perpendicular to x-axis. So let us take a point P. So this is called as, these two are double ordinates. Okay, so this is double ordinate of the parabola. So y square is equal to 4ax, then y is equal to what? Plus or minus root 4ax. Y is equal plus or minus 2 root ax. So if this is a point x, so this is x comma 2 root ax. Then this is the image of this one with respect to x-axis. So let us assume that this is p dash. P dash is x comma minus 2 root ax. So these two are called as double ordinates, right? Okay. Next, what do you mean by latus rectum? What do you mean by latus rectum? So these are infinite double ordinates are there. Now what do you mean by latus rectum? So latus rectum means if double ordinate is passing through focus, so we have infinite double ordinate lines. So from those, if a line segment like this, which is, or if a chord is perpendicular to x-axis, okay, perpendicular to x-axis and passing through focus, perpendicular to x-axis and passing through focus is called as latus rectum. Okay, so these are the definitions of chord, focal chord, double ordinate and latus rectum. Okay, now we will derive length of the latus rectum formula. Now derive length of the latus rectum formula. So this is the parabola, S a comma 0 is a focus, and let us take this distance as L, and this distance also become L. Okay, so then this point is a comma L and this point is a comma minus L. Okay, now what is the name of this parabola? What is the standard form of that parabola? Y square is equal to 4ax. Let L dash be the length of the latus rectum. Right. So now L a comma L point lies on is a point lies on 1. So it is lies on our parabola, so it should be satisfies our parabola. So that means substitute this point in the parabola, we will get L square is equal to 4a into, this is x value a. So L square is equal to 4a square, which is 2a whole square. So L is equal, L means length, we should not take plus or minus. So L is equal to 2a. So length, this length is 2a. So this length also 2a. Therefore length of the latus rectum L dash is equal to 2a plus 2a, that is equal to 4a. So 4a is called as length of the latus rectum of the parabola. Okay. Now some important properties we observed by just watching this parabola. So this is our parabola. So just by watching this parabola we can observe many points in this parabola. Okay, so those points are, so first of all, our parabola y square is equal to 4ax. Here a is positive, a is length. So length means it is positive. So for a greater than 0, y square is equal to 4ax. So here this parabola crosses, cuts x-axis here, that is called as vertex of the parabola, that is a 0 comma 0. Next here this is the tangent. Tangent means what? Where the line which touches our curve at x, only one point is called as tangent. So y-axis tangent at vertex. Okay, next symmetric about x-axis. So this parabola is symmetric about x-axis. So this x-axis is called as axis of symmetry, and the equation of axis of symmetry is y is equal to 0. Next, parabola only lies in two quadrants. Those are first quadrant and fourth quadrant only. So this parabola does not lies left side. This is left side. So curve does not exist on the left side of the parabola. So this curve opens right side. So first I said mistake, that is the curve open, not open left side, the curve opens right side. So our parabola y square 4ax opens right side. Okay, so curve does not exist on the left side. Next, as x increases, y is also increases. As x increases, y is also increases infinitely, like this. So this goes downwards, that increases upward, so they will not intersect again. So that's why this is open curve. This opens to right side. It is open curve. Next, equation of directrix. So this is x is equal to a, this point is minus a is equal to 0, minus a comma 0. Therefore the equation of this line is, which is perpendicular to x axis, that is x is equals to minus a. So x is equal to minus a means x plus a is equal to 0. X plus a is equal to 0 is the equation of the directrix. Next, length of the lattice rectum, just now we derived, this is the length of the lattice rectum, which is equal to 4a, and ends of the lattice rectum are, this is a comma 2a and this is a comma minus 2a. So these are the important properties of this standard form. Okay, now some interesting problems. So here I am going to explain two problems related to this topic. So first problem is, find the equation of the parabola having focus 3 comma 0 and the directrix equation is x plus 3 is equal to 0. That means x is equal to minus 3. Okay, so draw a related figure to given problem. Okay, so here focus is 3 comma 0 and directrix equation is x is equal to minus 3. So draw a curve which is equidistant from focus and directrix. That figure is called as our parabola. So the shape must be like this, which is of our standard form, y square is equal to 4ax, right? So what is the focus of the standard form? A comma 0. What is the directrix equation? X is equals to minus a. So therefore focus given s a comma 0 is equal to s 3 comma 0. So from this we will get a is equal to 3. So x is equal to minus a, x is equal to minus 3. Compare these two, you will get a is equal to 3. So what is our standard form? Y square is equal to 4ax. Substitute a value in this equation. A is equal to 3 into x. So y square is equal to 4 3 is a 12x. So this is the equation of the parabola if focus and directrix are given. Okay, right. Next, find the vertex, focus and equation of the directrix. Equation of the directrix of the parabola y square is equal to 16x. Also find the length of the lattice rectum. Okay, simple problem. So reverse of this problem. So y square is equal to 16x. Compare this equation with standard form, y square is equal to 4ax. Here 4a is equal to what? 16. 4a is equal to 16 means a is equal to 4. Now what is the focus of this standard form? What is the formula for focus? S a comma 0. So a comma 0 means 4 comma 0. Focus. Next, what is the vertex of this parabola? Obviously 0 comma 0. That means a 0 comma 0. Vertex completed. Next, equation of the directrix. You should remember the equation of the directrix to all concepts. Okay, or if you remember that graph and that complete picture, okay, no need to by heart those all things. So simply we will observe from the graph. So equation of the directrix is x is equal to minus a, that means x is equal to minus 4, x plus 4 is equal to 0 is the equation of the directrix. Next, finally, what is the length of the lattice rectum? What is the formula for length of the lattice rectum? Length of the lattice rectum is equal to 4a. 4a. What is 4a value? 16 directly. So this is the length of the lattice rectum. Okay, right, students. So this is the end of this lecture. So recall these all concepts, revise these all concepts. Okay, so solve related problems, interesting problems. Okay, thank you.